Hello, welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma. Today I have Saad and Birju. I hope I said that last one
Yeah,
correct. They are the authors of Flutter Box Transform, and they're also working together at Codelessly. If you guys maybe remember, we had Ray on from Codelessly a long, long time ago. Um, anyways, welcome, guys. How are you?
I'm good. Thank you for having us.
yeah, me too.
Awesome. I don't even know where the heck do we start. I mean, we were talking quite a bit before the show about why this package, right? And you mentioned that part of this is from Codelessly. So why don't we kind of touch base on what is Codelessly and what's going on with it, and then that could probably lead us into the package itself, the origins of it.
So Codelessly is our Cloud UI, app to Cloud UI or Cloud UI to app product. So it's like this editor that converts your designs into full apps, and it's a full-blown editor, right? So it has a lot of internal mechanics. It has a lot of internal machinery that makes it work. A lot of those mechanics are very simply resizable boxes. You have a box that needs to be resized horizontally, vertically. You hold down the shift key, it scales instead. It has your average resizable boxes as one of its main features. It also has other parts that utilize resizable boxes, such as crop overlays and image alignment overlays. And I think there's one more I'm forgetting. But Codelessly, because it's an editor, a full blown editor, kind of like Photoshop, more like Figma, I should say, more like Figma, and it's like usability, and it's like physical usability, not its mechanics. There's a lot of resizing that goes on. You need to resize an element. You need to resize an image. You need to specify the width of a specific text node. A lot of resizing happens. So the resize mechanics, they need to be pretty good. They need to be really really solid. And because Codelessly has a whole layout engine, it has and it has like all these overlays and and resizable boxes, we found ourselves needing to re-implement the same resizable boxing mechanisms, the same resizability mechanics, the same shift scaling thing, the same symmetric scaling thing, same dragging thing. We had to pretty much do that, write that code like over 3 times, if not more. So Birju and I, since we kind of share the same work, we kind of hop between each other's work. So we found ourselves kind of frustrated that this works one way, that works the other way. Oh, but this needs a special edge case. That one needs another edge case. This one works, this one doesn't. So we were like, hey, resizing is more complicated than we thought it was. And we'll talk about that more later. But resizing a simple box, it could be that it sounds like the simplest thing ever, but it can quickly, if you really like try to hone in on it, it can quickly turn into a shockingly complex mechanism. So we sought out to make this package, and we made it open source because we found it that the mechanics we implemented were so complicated to the point where we realized not a single package for Flutter, not a single package in general, so not just Flutter, every editor we opened, not just Codelessly, every editor, including Figma, including Photoshop, all Adobe products, and a few others, like some obscure ones we found, none of them have every single feature that Box Transform implements. And we'll get to that later. But we realized that, and we were like, oh my god, we have to share this with the world. this is pretty much the best, for as crazy as it sounds, the best resizable box in the world. Such a simple thing. So that's how that came to be.
Yeah, initially we were like somewhat impressed by what Figma was doing. So Figma supported these different resize modes where you can press Shift or Alt or both together to like get into a different kind of resizing. And we kind of wanted very similar features for us in different scenarios. But it was kind of hard to do that because we were also restricted by constraints and clamping, which Figma doesn't normally do. Yeah. So we implemented all those things together, and we abstracted away everything into an algorithm that can live in a pure Dart package, and then our Flutter package just leverages that algorithm to do everything with Flutter.
I find it interesting that, before the show you said that this package is very, not very much to talk about, but you have an algorithm behind it. You have so many features that other ones don't have. Please don't play down your package. I mean, this is your package, right? You're saying your work is not valuable, not good enough to talk about. I mean, it sounds very interesting.
Oh my god, where do we start? So Virgil and I innocently started writing it from scratch, thinking nothing of it, because we weren't copying over code. Because every implementation we wrote was different and unique. So we were like, okay, let's try to make this from scratch. And we started off. We did. It was working fine. Something very basic. Little did we know, there were just little things, little mechanics that bothered us. Tiny things. Like, okay, we have this resizable box. Oh, but it needs to be clampable. So you need to have a bigger box around it that limits it physically. And okay, that's fine. We implemented that. But now there's, oh wait, what if I only want constraints? So only limit minimum sizing and maximum sizing instead of just a clamping rect. So we added that. And those produced undesirable behaviors like, oh, when you reach a minimum size, we have a whole flipping mechanic, right? So when you go, if your box is like this and your cursor is from the right edge and you take it to the left edge and you go beyond, the image itself flips, right? It's like how most editors or image editors work. So we're like, okay, we need flipping mechanics too. And wait, when you hit the minimum size of a box and you try to flip it, it needs to stop at its minimum size and then snap to the other side. That was a whole rewrite. Then we were like, okay, when you scale resize, when you resize a box and keep its proportions perfect, so you hold down the shift key and you hit the most bizarre things. You hit the edge of your clamping rect. It needs to stop there on one side, and the entire operation needs to stop. Like if it hits a wall, it needs to stop. There were like 6 edge cases with just that. We had to rewrite scaling like 6, maybe 5 times. Then we wound up over engineering the whole thing because things got carried away, and we wound up needing to ray trace or some version of ray trace. I'm being dramatic about it, but like basically like line intersection math. So it kind of just grew and grew and grew and got more complicated and more complicated. Eventually we had to add a whole, every scale mode or resize mode needed its own file because every algorithm was so complicated, because some very subtle features just weren't good enough for us. Like, and there were some issues, like a simple issue would require a massive rewrite. For example, one big one was our first version. We had a simple box, and when you try to resize it and it hits an edge, the resizing continues from the other side. We called it resize overflow. So basically, it hits an edge, like your clamping rect edge, so your box kind of hits a wall from the right side, and the left side grows while your cursor keeps moving. So that was called resize overflow. And for version 1, we were like, oh, it's a feature. But then we were like, no, this is not desirable. That took us down a massive rabbit hole. Apparently no editor we know actually implements clamping rects and constraints and all the fancy stuff we support. Though that simple feature alone is simply not there. So our problems were kind of unique. We couldn't take inspiration from other from other editors because this was such a unique issue. And it was shocking to us because it's a simple resizable box. We weren't expecting too much from it. And that just kept spiraling, and we kept going further and further and deeper and deeper, and just got more complicated and more complicated. Eventually, we reached a point where we're actually very happy with how the mechanics are. and it required actual months of free writes. Is that right, Birju? Do you want to talk
Yeah,
about
I
that?
think it took like maybe 2 or 3 months because we rewrote the whole thing 3 times.
Do you mind to kind of go over what is clamping? Because I always hear that term, and you guys keep mentioning it, but I don't think I'm the only one who's never heard of clamping, right? I've seen the word clamping used in multiple contexts, but when you're saying clamping, what exactly do you mean?
Sure. So when you resize a box, you might not want your box to resize, let's say, outside of your viewport. So what you do is you create an invisible box that is maybe same size of your screen or your playground, which limits the box resizing to not go outside it. So you may have seen this if you have ever implemented a simple resizing, a very simple version of resizing where you just drag your cursor, you take that delta or difference in the cursor position and you add it to the position or size of the box. In that case, if you keep dragging your cursor, let's say, into your next screen or outside the screen, your box continues to grow because it doesn't know where to stop. So in those kind of situations, you can just create an invisible clamping rect. You can say the resizing algorithm that do like resize the box but don't go outside these bounds. So resizing algorithm checks for that. If your cursor is outside that, it stops the box from growing or shrinking, and whenever your cursor comes back into that viewport, it again allows to resize the box. So that's what we call a clamping rect.
Okay. Yeah, I think we have nothing like that in Flutter already because it seems, I mean, it kind of sounds like a constraint box to a certain extent, but that I think is different, right? That's stopping something from ever, that does, when I start to explain it, does sound similar, right? What would be the difference between a constraint box and a clamp? Sorry if that sounds maybe too simple. Maybe you can help me to understand.
Yeah, so when you say constraints, you define how large or small your box can be. So, for example, the min width you set it to say 100 and max width is 500. So that's the range your box can grow or shrink to. In contrast, clamping is not something that limits how big or small your box can be. It just limits to the point where your box can't grow outside. So, for example, if your box is in the top left corner of your playground or your screen, and you start dragging the bottom right corner of the box, you can grow the box until you hit certain boundaries, right? So in that case, that can be your display, that can be an invisible box that you have defined, but that doesn't mean that your box is restricted to specific constraints. Now, constraints and clamping, you can use them together as well. So it can check whether your constraints are more restrictive than your clamping rate, and based on that, it will make a decision and stop uh, resizing the box. But fundamentally they are different things. As I said, the constraint's gonna limit your width and height, whereas the clamping rect decides the position of the box and the area from the area outside which the box can't go. So it's more about positioning rather than just sizes.
You can think of it like a crop overlay. So if a crop overlay cannot go outside its image, right? When you want to crop an image, you have the little grid, right, to crop it. That grid cannot escape the image's boundaries. Those boundaries are the clamping rect, for example.
Gotcha. But we have nothing like this already in Flutter to help with this problem.
There are some basic, very basic packages that can do this. So I think I remember there's a crop package that shows a crop overlay that has a very like rudimentary clamping rect. However, see that's the thing. That's the thing. Clamping rects are simple. You just stop the resize operation when it hits an edge, right? It's so simple. But we have scaling, freeform resizing, scaling, symmetric scaling, and those mechanics all compound together and create something significantly more complex than we expected. Scaling alone is like the hardest of all of these mechanics, because if you get to the technicalities, it's actually shockingly complex, because you have to keep the aspect ratio perfect, and you have to keep the cursor. You have to keep the box following the cursor at all times. So it was significantly harder than we expected. And no package has all of these together. Nothing, absolutely nothing. Nothing has all of these features all together all at once. We took a lot of inspiration from Figma. Like the resize modes come from Figma. Like you hold on Shift for scaling, you hold on Alt for symmetry. You hold on both for symmetric scaling. But even Figma doesn't have clamping, and it doesn't have constraints. In Codelessly, since we have an entire constraint engine, we have an entire layout system, we have to limit resizing. If you resize a button, it cannot grow outside of, for example, the screen that you're gonna have it in, or the box that it's in. If a what's a good example? If you have two boxes inside of each other, the big parent cannot shrink smaller than its child, right? It can't be smaller than what it's containing. Those are pretty much our inspiration for even wanting clamping and constraining. At some point we started to question ourselves, what if no editor we know has clamping and constraining mechanics at the same time with scaling and symmetric resize and all these resize modes, is it even wanted? Isn't even a desired thing? And Codelessly was our motivation for that. But every editor we looked at, they're all meant for designers. They're all meant for free form. Put this image here, put that there, etc. Resize this, shrink that. They're very simple freeform mechanisms. There's no clamping and constraining required. There's no layout required. There's no rows and columns and grids and all that stuff. So no editor we know cared to implement clamping and constraining. So it was a problem that was unique to us, and that's what compounded all these mechanics together. It's what made things very, very complicated.
I mean, you said you wrote this something like 6 times, right? Using the whole thing, or just the clamping section, if I remember correctly?
3 times the whole resizing portion of the package. It can also do dragging, but dragging is pretty much straightforward with clamping and everything. It doesn't involve constraints as much, so there is no like much conflict. So that was straightforward, and I think we wrote it correctly in the first run. But we had to like keep refactoring resizing because we kept finding these new use cases and features we wanted, and we kept refining it, and some things might not just work because of how we wrote them. So we had to like scrape some parts and write some things completely from scratch, and we ended up doing it 3 times.
The other three times are from the Flutter side. So we had to refactor how the transformable box widget is implemented. So it now supports controllers. It has a more refined API. It's more in line with Flutter's standards. We had to pretty much redo that like 3 times at least, if not more. I'm not entirely sure.
Oh, I didn't even know how do you even. I don't even know where to even start. Like, how is the feeling to have to say, "Oh God, I have to redo this again"? Right. I mean, is it like you start with a brand new code base, or you're just saying like, "All right, let's just tweak until we get to what we need"?
Yeah, so there are certain things involved, and there are certain steps that you would perform. So like you apply the new delta that you get from the cursor event, and then you do resize, you check for constraints, you check for clamping. So there are these steps which you can't avoid. And when you are facing an issue, that issue could come from either of these steps. And because of the involved complexity of all of these steps, it pretty much gets harder for us to debug very important issues. So in cases where we can't just fix a single issue by changing, say, a few lines of code or changing how this process works, what we ended up doing is just commenting out everything, like the whole resizing function, and start writing it from scratch. Or if we have a hint, which part is affecting. For example, if we know that the issue comes from constraint, that then we can just rewrite that part, and that's how we proceeded with issues. And that's how we ended up commenting a lot of code and rewriting and then refactoring, and same cycle keeps going.
Now, when you're rewriting something, do you have like a set of tests that you're writing against, or is it just you're just kind of writing it blindly and kind of testing manually as you're going along?
Do you want to take this one, Saad?
Is it like some of these questions are really difficult and you guys keep passing
No,
back
they're
and
just kind of funny to answer. Because again, we're talking about a simple resizable box. It's supposed to be simple, and we keep bringing it up. Like in our meetings together, we would keep making like jokes like, "This is supposed to be a simple resizable box. Why is it so complicated?" For tests, no, we didn't have tests because we were still trying to fix the mechanisms. We were never really pleased with the mechanisms until the very end. So tests, if we had written them from the start, they would have kept breaking because we discovered the little nuances that were desired during the development process, not at the start. So if you notice, the simplest thing, for example, in Figma, if you scale resize, the edge of the box that you're resizing will always match the cursor no matter what. It will always be the pixels will always hit the cursor. That simple mechanic alone took us some time to figure out that we wanted that and we needed that specific. We can't have this package without that. So that was an iterative step. Other features were resize overflow. We published the package initially with that as a full-blown feature. Like, hey, we have something called resize overflow. And to remind you, it's when you hit an edge while resizing, like the clamping rect's edge, and you try to keep going, but the other side grows instead. And we were like, yeah, this is amazing. So we published that as a package, and later on, we were like, no, I tried to implement a crop overlay, and this feels wrong. It just straight up feels wrong. When I hit the edge, it should simply stop. So we kept iterating, and now our desired output changed. So if we had written tests, they would have broke at least 4 times or 3 times. So the development process pretty much involved me and Birju in like 3-hour meetings, maybe 4-hour meetings, pretty much like co-programming together, and a lot of debugging, a lot of annoying math to deal with, so a shocking amount of line intersection math, and a lot of it was just that we just kept commenting out large blocks of code and writing new functions for them and going back and forth, even like stepping into some editors and analyzing their behavior and mechanics for some features. Up until the very end, or up until like 2 months ago, we were finally happy with all of the mechanics. We were finally like, yes, this is exactly what we expect. This is perfect. And we wrote tests in an interesting way that I'll let Birju talk about.
So writing tests for all of this was so much tedious, because even with a single handle, there could be a lot of different scenarios. First of all, we had 4 different types of resizing modes. You can just do freeform, you can do scaling, you can do symmetric resizing, and there is also symmetric scaled resizing. So there was 4 resize modes. Then comes constraints, clamping, and there are a lot of things. And this was just about one handle. We support 8 handles, 4 corner handles and 4 side handles. So you can imagine how much amount of test we have to write. And another problem with writing tests manually for this is the numbers. So like you have to statically or yeah statically define the positions of the box and sizes of the box and what you would expect when certain deltas are applied for the resizing and dragging. And that's really hard. Like I wouldn't say hard, but tedious to calculate for so many use cases. So what we ended up doing is implementing a UI test recorder inside the playground of the example app that we built, and we kind of used that to like auto generate all the test cases that we have right now.
Yeah, I mean, I don't really work too much with creating these kinds of new packages, and I understand that writing stuff for the UI can be quite complicated. When I say stuff, I mean the test itself. But like generally when I'm programming, it's hard for me to not write a test first because number one, that's the way I train myself. Number two, like I want to make sure that what I'm doing is correct. And working with other developers, I see a lot of people manually testing stuff. They have to reset up the manual test, try it, see it doesn't work, make a change that think will work, and then reset up the test and repeat many times, which takes a long time to do rather than just running a single test manually or sorry, automated style, right? That's why it's like I'm it's curious to hear like how you guys work, right? To me, again, that would be the way, but I guess I can see how difficult it would be to keep that in sync, and also it's like, well, actually, no, my previous test is not testing things correctly, or it doesn't work because I'm rewriting this from scratch, and you have to turn off these tests, and maybe that test is no longer valid because actually that is going against the new style that I'm writing for, right?
Exactly. Yeah. So like the test that we have right now is mostly for the your Dart package where the algorithm and all the processes live, because that's the core of all the package. And if we were writing test cases initially, what we would end up is a different API every time we refactor stuff. So even if the test cases and the data inside those tests work, we end up refactoring those because say we renamed the method, we changed the number of parameters you need and stuff like that. So it would kind of get tedious to do that every single time. And when we didn't have that much time on our hand to like write test first and then develop the feature, because only developing the feature took us like more than 2 months. So that's why we tried to avoid writing tests initially, because we knew we could just visually confirm what's working and what's not. And we kept adding new features and everything, so that made those tests kind of unnecessary initially.
What about regressions though, right? Because as you're adding new features, you can easily break an old feature that was working properly.
And that kept happening.
Yeah, I can imagine, right? Because as you said, this is supposed to be a simple box, but as you find out, sometimes things are not so simple, even though they look simple, right?
For tests, especially like what for our team, we have each of us has a unique way of pretty much solving problems. For Burjo and I, we found that the tests were the wrong way to go about the development process. It has to come at the end rather than the start, because we kept iterating over everything, and because we kept changing the API. That wasn't the only thing that was the issue, though. Even when we finished everything except for we were like, okay, how are we gonna write tests for this? Because again, there are so many variables. Every handle needs its own suite of tests. Every single handle has four different resize modes. Each resize mode needs to be checked against each corner of a clamping rect and against constraints, and both at the same time. And if you sum up all of those tests together, you get a colossal number of tests. Even if we wanted to write tests first, it would simply be unrealistic and impractical. It would be impossible even. So generating the test, we actually generated. Let me check. We generated, or Birju wrote or generated 200 tests to get complete coverage. Or is it complete coverage, Birju?
For the Dart package and resizing, yes, we don't have test for dragging, since it is so simple. We never wrote them yet. But yeah, for resizing, it covers everything.
Every single thing, every compounded test. So every combination of elements, every handle, every corner, every clamping rect edge, every constraint with min height, max width, max height. Those are four alone, by the way, and their combinations together. It compounds very, very fast.
Oh yeah, I mean, I, I I just remember hearing that you had all these edge cases that you needed to support, and I thought adding each of those edge cases would alone just be at least one test, right? that would be definitely one way to do it. You're like, okay, I need this one, I need this one. Those would be the tests that rather than saying, okay, I have to test every single line, right? I mean, and also when you generate the test, right? How do you know that these generate tests are actually, I don't know how you say it, like exhaustive enough that you have confidence, right? Does that make sense? Like, because you are generating tests, right? So I don't know. I'm still skeptical about generated stuff because sometimes it works. Usually, not trying to say you don't know how to generate code, but I know my coding and I don't trust it. Usually, that's why I like to have some tests to make sure. Okay, these things I know that I need to work. Okay, do they actually work? Yeah or no? Sometimes you get surprise things, right? And then sometimes I get user input that I didn't expect. So then I take that unexpected input and I use that as my test case to say, okay, this fails. Okay, let's make it pass and then make sure we have no regressions.
Yeah. So when you do code generation on test, you are right that things might not be perfect or the way you want, and that's why we avoided completely generating everything automatically. What we basically do is integrated, we basically wrote some tools that can record our actions when we perform resizing on the UI. So for example, we had our playground where you could like control the box sizes and all the flags and everything, and you could play with the box with clamping racks and everything. So we made it so we integrated our recorder inside that UI, and you can press start button and it would start recording your actions. So while you resize the box, you have a visual cue that whatever action you are performing is yielding right results. For example, if you hit a clamping edge, your resizing stops there, right? You can visually confirm that your cursor keeps moving, but the box doesn't resize anymore. So that what the test should do as well. So that's how we made sure that all the tests that we generate would also have high quality and adhere to all the rule set that we define, not just like giving it some parameter and letting it generate everything by default.
Okay, but maybe we should talk about some more features of the box. We've spent a lot of time talking about testing, which I think is important. We talked just about clamping alone for a long time. I mean, looking at the page on pub.dev, you talk about dimension constraining, which I suppose I know that's different than the clamping, right? I mean, you have different features on here. Maybe we can kind of go over what else you think are the big features that people should consider about when looking at Flutter Box Transform, right? So besides clamping and all around there, what else should I be looking at when evaluating this package?
Flipping is a big one.
But when you said flipping, right, you're talking about when you take the box and when you drag it and you go to the other side, it'll actually reverse it. Is that what you meant flipping?
Yeah. So these features, they could be so subtle that you might not notice them when you use them in other editors. For example, Figma also supports flipping and all for kind of resizing, but you may never think about it because it feels so natural to use. But when you pay attention to all these little details, you can clearly see that how many different kind of ways are there that you could resize a box, or you could think about a 2D box which was supposed to be so simple.
It's hard for me to understand about the flipping part. You're saying like left would be right, right would be left, up would be down, down would be up. This kind of flipping. It's hard for me to imagine why I would want something like that.
This package can be used for cropping and resizing content and UI and stuff, and can also be used for developing a simple boxes or drawing or maybe paint. So in these kind of use cases, you always see that when you want to create a rect, what you would do is you select your rectangle tool or something, and you just drag on your canvas. Now that drag can also flip as well. Most of the editors, almost every good editor supports flipping, but it's so natural that you might not notice it. But if you just write a very basic resizing and basic box creation, it's not gonna support flipping. That's why we had to like actively think about it and see how it could play with other parts of the package, because when you flip, all the handles are different now. Like basically they are opposite, right? So we have to flip sign, we have to flip the math, we have to change handles and everything. We also have to calculate new clamping boxes, and also it also changes the ray tracing that we talked about a bit. So that's why flipping was so much involved, rather than just being very easy. Because as a user, if you just integrate box transform in your package and you try to resize a box, you would feel that it is very natural to resize in any direction. You could like just press shift key and it's gonna persist your aspect ratio and stuff. But these things have like specific logic written behind it so that you could do it. So from a user's perspective, this might not seem like a big deal, but as a developer, so much goes into making that box flip.
And again, they get compounded. The features compound. So minimum constraints. Your cursor stops at a minimum constraint, but you can still flip it if you exceed the its limit.
Okay.
That's still a feature. That's not something Figma supports. That's not something any editor supports, and yet it feels perfectly natural in our package. I expect it's going to be one of those packages that's going to be very underappreciated when you use it, because the features are just so natural to use. You don't expect them to be complicated. That's how you know it's doing a really good job.
In most cases, any crop UI would have flipping, any good crop UI. So if you take an example of Lightroom or Photoshop, if you create an area with your tool, you should be able to like flip it, because that's very natural, right? That's what the users are used to.
And by the way, there's two. Flipping can mean two things, and we support those two things. Flipping, when we say flipping, we can either mean, oh, when you reach the zero width or zero height of a box, it just goes to the other side, but the content stays perfectly the same. It's just that your box can just resize against the opposite corner as an anchor point. So the box just flips around, but the content stays. The other definition of flipping is the content itself flips. So the content, for example, mirrors horizontally or mirrors vertically. So those two things, we support those two use cases, and the latter is the one all design actually both of them all design tools support. So for Figma, if you want to mirror an icon, you want to mirror an image, you would actually take the left edge, or sorry, the right side of a box and flip it around physically. You flip the box around with your cursor. For cropping or resizing, you can also flip the box, and it'll, for example, the crop UI, it'll stay the same. So you can flip it and it'll stay the same. No flipping, no content gets mirrored. So those two things, they are, again, Birju said it. It feels so natural to us. We don't even think about it. We just expect it to happen. And they are generally simple if you don't have
Constraints.
compounding
Yeah.
features like constraints and clamping rect.
Yeah, I can already imagine now that I'm thinking about it. So many times when you're creating a design, you may want to have a symmetry, right? So you want to have your design and you want to be able to flip it. So you could basically use your package as part of the piece of, say, duplicating that thing and then flipping it to the other side, right? That could actually be done using this package.
Yeah, flipping is such an underappreciated feature. You won't notice it's gone until you want it. Mainly designers will care about that feature specifically. It's mainly designers, but it's pretty much a core feature. And again, it's flipping alone. You need to. It's so simple, and yet when it comes to clamping rects and constraints, they genuinely compound to such a point where the math gets so exponentially complicated that it took us months to refine well. Every single function we have, every single math function we have, passes a flip parameter to make sure that we're handling the flip mechanism. Same with constraints and clamping rects. They all get passed to every single or most functions so that we ensure that we handle those cases compounded together. If you resize in our debugging session and our coding sessions, we reached a point where we had to render two overlays to show some hidden boxes that are being calculated internally. So we have something called an available area. We have something called what was, I forgot what they were called, but there were like 3 boxes or 2 boxes other than the other than the line intersection math that we had rendering all the lines and points. Yeah, when it came down to it, in our debugging sessions, you'd call us crazy for what we were doing in our UI, because it looked like something out of a 3D program. If anyone's interested, you can look at our Twitters, our Twitter profiles. We have some clips of some of that insanity going on in our coding sessions.
You recorded the coding session so we can actually watch.
And just the like the UI, like, just rendering some debug boxes, some hidden internally computed boxes and stuff like that.
Yeah, I also find it. So this was done from your work with Codelessly, but it's underneath hyper designed, right? So is it that you guys are working together on as another entity, or what's how come hyper design as opposed to Codelessly?
So box transform is separate. Birju and I wrote this outside of our company, so we had no influence from Codelessly. Even none of the code we used is even from, like, everything is completely separate. We wrote the thing from scratch, and we wrote it together outside of the company. So that's why, and we needed to publish it under some name. So we thought, okay, let's make a team name. Just it's nothing form or like super like formal. It's more just to have a title. It's basically whenever Birju and I, maybe others, if anyone's interested, we have some very specific project we want to work on together. We just put it under hyper design. It's it's um, it's mainly for open source projects. It's nothing, nothing specific like that.
Okay, that makes more sense now. Yeah, I mean, what else are we missing? I mean, it sounds like a lot of stuff already. You're talking about the handles, the clamping, the flipping. What else are some good features from the box?
Yeah, I was thinking of talking about the resize mode callback, since it is quite important on controlling how the resize mode works. So yeah, we support four kind of resizing modes, but they might not always what you want. Yes, it gives you a lot of features, but what if you wanted to just have a simple box and very limited or simple resizing? You don't want to support like scaling or symmetricity or anything, just a free-form resizing. So we had to implement a way that allows user to control this. So what we do is we expose a callback which you can pass to the widget. That callback decides when to switch these resizing modes. For example, by default, if you don't pass anything, if you hold down your shift key, it's gonna go to scaling mode, and if you hold down your alt key or option key, it's gonna go to symmetric resizing. But what if you wanted the scaling mode to be default when you don't hold any keys, right? And you want to toggle the behavior actually. So if you hold the shift key, it should do freeform resizing. So you could do that with that callback, since we have to like listen for this keyboard events and stuff, and it might involve focus system. So we made it a bit explicit to the user, so the user can have total control on different kind of resizing and when those kind of resizing gets triggered. And we also have widgets. So for example, we have these handles that you drag to resize the box, right? So there are corner handles and side handles. So we provide some default implementations of those handles. So you could have like corner handles and rounded handles, square handles. So you could just get started with those handles. You don't have to like write your own widget or anything, but if you ever needed to, you could like override those builders and provide your own handles. They also support alignment, so you could like move your handles inside your content box, or you could move them outside as well. So it's totally flexible, totally in control of user. While keeping it that way, we also provide some default behavior and default widgets to get the user started.
Customization was actually a massive push to how we wrote the Flutter part. Our customization was like the number one priority for us, and that and accessibility. So we made sure that the widget works perfectly for touchscreens, and it works perfectly styluses, Apple pencils, and stuff like, and it works well for iPad. We made sure that the corners, for example, and the handles have a tap region, sort of like how material design has a splash radius, or sorry, not splash radius, a touch radius. So you don't have to put your cursor directly intersecting with the pixels of the corner to resize. There's a little bit of leeway for accessibility. And on top of that, every single part is configurable. You can even hide some handles while showing others. You can show some handles and disable others. We made sure that every single part is as configurable as possible and as easily as possible. We even have an internal, not internal. We even have an angular corner handles for crop overlays we provided by a default implementation of that, because we know that that's one of the most common features that people would want to use the package for cropping, and other than the design. So the default handles are like circular, but if you want crop handles, we kind of made it for you. If you want, you can use your own. You can make your own with corners or drag handles. But we knew that was the case, so we added it anyways. So it's right there for you.
I don't know. Do you guys feel like now you're, I don't know how to call it, total experts on making boxes and things like that? Because this is, since a lot of effort you guys put into this.
We didn't expect it to be. I'm gonna be honest with you. It was quite the
Yeah,
rabbit
it just
hole.
started with a simple resizing, and then we thought that this doesn't feel natural. We are missing something. What we are missing, and we took inspiration. We checked other editors why they feel so much natural, and then we kept adding features, and then we had some features that we wanted, but no other editor had, and that's how Box Transform is right now. It comprises all these features which you can use in very simple paint, or drawing a kind of canvas, or in complex layout building and stuff as well.
Well, what's actually coming to my mind is I'm kind of curious about where do you learn how to do all these things, right? I don't even know what you even Google search for. I mean, what was your resources? I mean, obviously, what would you call it? The experience resource, like you said, was live. It sounds like Figma and maybe a couple other editing programs. But where do you get the implementation resource information, like how this stuff actually works?
So we had to write resizable boxes like 3 times in Codelessly. So I'd say we gathered a fair bit of experience by implementing it in 3 different ways. And we noticed, like, okay, we can do this better, we can do that one better, we can do the third one in this other way. And we kind of started with some base in Box Transform, and it just kept going and going and going and iterating over iteration. Line intersection wasn't even a thing until like the 3 months ago, maybe. We kept working on that part for like over 3 months. So yeah, the inspiration was from other editors. The mechanics desired, like Dynamic and constraints, came from Codelessly. The experience came from Codelessly.
Okay. I was curious if there was, maybe you went to Khan Academy to learn some special math that kind of understand how this stuff works. Because it sounds like there's a lot of, I don't know, spatial math. I don't know. I forgot what that's actually called in math, right? There's a lot of different math involved they have to think about.
So it was more like eureka moments. I remember Birju and I were, I think we had Codelessly open or Figma. I don't remember. We were analyzing it, and we had like screenshots of the exact behavior we wanted, like how the cursor should move from A to B and what the expected box would be. And it was specifically with scaling, a scaling compounded with clamping rect. So the scaling, when you hit an edge on a clamping rect, it should stop the whole operation, which is not as easy as it sounds. It is not as easy as it sounds. No one's gonna believe me until they read the code. So we were analyzing the images we were playing around in, and there were eureka moments. Like we kept looking at the screenshots in the editor for like a solid 30 minutes, maybe an hour, trying to figure out the proper math to do this. And at some point, I was like, Birju, this. I think if you imagine this line going from this point to this point, and its intersection with this edge, that's our stopping point. I was like, I think it looks like it might be, and we kept like analyzing, going back and forth, and like, yes, this is correct. Yeah, I think that's right. And let's try some code and look up some line intersection math, because again, that's shockingly more complicated than it sounds. And it's just again, it was literally just iteration, eureka moments, inspiration. It was just like that the whole time.
We also ended up writing a stream inside the core package because we wanted to visualize some parts. For example, we were calculating effective area and max clamping racks and stuff to like determine how big or small our box can be, but there was no way for us to make sure that those calculations were correct. And our API at that moment wasn't that flexible, so that we could pass all this debug information back to the Flutter UI, because this was a pure Dart package initially. So we ended up writing just a simple stream that throws out this metadata to the UI, and then we render some UI on that data and can visualize what our calculations are doing. And then we made some decisions based on that we need to change this specific part of our code to fix this issue and make it more flexible and stuff.
Okay, so it sounds like a lot of trial and error to make this thing work, and that's definitely another format to do.
Definitely trial and error. There was no way to predict where we were headed with it. Every time we made a feature, there was no way to predict its outcome. Impossible, because in the end, the Dart package is working with raw numbers. We had to implement so the size class and the rect class, they all come from Flutter, but this is a pure Dart package, so we had to implement our own versions of those called dimension and box. I think, was it box?
Box, yeah, because we couldn't use rect, it may conflict with Flutter
because the keyword's taken, and we had to have a whole class just to translate the Dart classes to Flutter classes and back and forth. There was a whole translation
so
layer.
the user don't have to like deal with our packages. If they are like using this for Flutter, they can just use Flutter classes. But if you need a pure Dart version and you want to like offload this to some other threads or something, you should be able to do that as well.
There were several motivations behind separating, making two packages, one for pure Dart and one that just uses it for Flutter. It was mainly so that if you wanted to, you can move the entire resize computation to an isolate. Even it's not heavy, the computation is not heavy. However, if you desired it for some reason, that option is perfectly available. And servers. So if, for some reason you wanna send your resize operation, you wanna make sure that your server validates the whatever the client's doing to resizing boxes in with some legal values. That's entirely possible. So we made sure to do that.
And if you don't want to use the widgets that we provide and you have some advanced use cases, in those cases you can just use the pure Dart package and have the algorithm at your disposal.
So then the Flutter one is probably relying upon box transform, right?
100%.
Flutter box transform is okay.
And it was one of the major. It is pretty much the reason for a lot of API decisions, because like midway through we transitioned to a complete controller API, and we tried to align it as much as possible with Flutter's etiquette. If you, I guess, yeah, etiquette is the right word. Everything is. I think we have pretty much perfect documentation on everything. Everything is very well documented and written in very specific API friendly ways, so that anyone can look at it and they can almost see Flutter's own code.
Okay. Yeah, I mean, this package is definitely interesting, and I can imagine with how Flutter's going around, we will be seeing more and more kind of editor based, like Figma design kind of things, and obviously we will see that with Codelessly someday. So I can imagine, this package would be quite useful, and like I said, it's going to be an underappreciated package for all the effort put into it, right?
Most likely.
Are you That's kind of like the life of a quote unquote hero, right? It's like when things are, all the effort that's put into these simple, what looks like simple things, kind of gets underappreciated. And are you okay with that, or or I don't know what else to say. What else can you do? I mean, you kind of just have to accept that. Okay, I know what I put in was a lot of effort, and I'm happy that it makes people's lives easier, even though they don't understand all the complex involved behind it.
Well, it's how you know you did a good job, isn't it? when no one really uh, sees it, it's how you when it gets hidden behind, like for users they don't notice it. That's how you know you did a perfect job. And the best we can do is pretty much just talk about it. No one's gonna really understand how complicated it is unless we talk about it, right? We wrote a Medium article detailing how to make Figma's exact resize UI. So if you want to mimic Figma's exact mechanics and look and feel, you can follow the blog post to see how that's done. And that kind of it gives you strong hints about how complicated things got. Not from the packages, not from like making it side, but internally what's going on, basically the internal mechanics. You kind of get a hint that things are a little more complicated than they're meant to be.
Yeah, I definitely can imagine. We reached the end of our time together. I mean, is there kind of one last, or maybe a couple last things you want to say about Flutter Box Transform, or maybe looking for some more people to come try it out, or let people know why maybe they should use it? Like, what kinds of problems would this be solving? Who would want to actually take a look at it?
So whether you are writing very simple resizing, it could be for say cropping, could be for like rearranging some elements in your canvas or playground and stuff, or you are writing complex layouts and complex editors. Box Transform can help you save a lot of time because it contains mostly like I would say 99% of the things you would need for resizing, constraint, clamping, you name it, and you can just focus on your core features and everything, so it should boost the development time for them, definitely.
Yeah, like resizing boxes are such a common feature when you develop. You probably there's a very strong chance you might have written one before, or you might write one soon. If you plan on doing that, Flutter Box Transform is pretty much the package to use, at least for now. um, it is we made it sound it is very complicated internally, but it's dead simple to use. We made sure that it is so easy to use. Everything is right there out of the box. Everything is configured exactly the way you expect them to, and you can configure every part of the way very easily. We made sure it's as easy to use as possible. No, so like Birju said, no matter what the use case is, if you have a very simple thing to resize, if you just have a resizable panel, if you just want to have a simple thing, I don't know, you can use it. You can use it and it'll work perfectly. No compromises. And it's just not what features you might need, it's every feature you will want. We made sure to cover every single thing. If there is a feature we never covered, please feel free to join our Discord and send us a message.
Well, how can they actually find the Discord? Is it on pub.dev on the Flutter Box Transform?
It's in our pub pages, and
It's also on our website of hyperdesign.dev. Yeah.
Okay, cool. Well, again, thank you guys for coming on. The reason I brought you on because I mean the package has a lot to it, and I know there's a lot underneath the hood involved in it. So I wanted to kind of get this package some recognition because yeah, like you said, I'm sure there's many people who probably need at least some features on here, but they don't know about this package. So you should definitely take a look at it.
thank you for having us on.
Yeah, it was great. And thank you for coming on.